All right, for the time being, we've just got one more example regarding independent events. So let's take a look. We've got these two identical components, and a system can succeed if at least one of the components succeeds. Assume that the component fails independently. The components fail independently of each other. So whether one fails or not has no influence on whether the other component fails or not. And the probability of each component failing is 0.09. So would it be unusual to observe one of them failing? And in general, an unusual event would be an event with a low probability, 10% or 5% or 1%. That definition can slide, but to this point right now, unusual would mean a probability of lower than 5% or less than or equal to. I forget exactly whether it's less than or less than or equal to, but that won't be relevant for this example. I'll just type less than 5%. And so 9% is not less than 5%. And so no, it would not be unusual. Them to fail. But would it be unusual to observe two components failing? Let's bring up the calculator for that. Since we have that these events are independent, 0.09 times another 0.09. Or we could have typed 0.09 squared, since we're multiplying a number by itself. Either way, we're getting 0.0081, which as a percent would be 0.81%. That would be less than 1%. So yes, probability is 0.081 or 0.81 as a percent, which is less than 5%. Now, we're actually going to use that previous answer to answer this part. What is the probability with a parallel structure with two of these identical components that it will succeed? Well, the probability of succeeding is that at least one would succeed. And that is the complement of both failing. See if I could stop the share here for a moment. The number of components that are succeeding, since there are two of them, would be 0, 1, or 2. And going along with that, if you have 0 succeeding, that's 2 fails. If if you have exactly one succeeding, the other one fails. Or if both components succeed, then 0 have failed. So, looking back at the information and the question again, remember we were told right at the beginning, the system succeeding would be if at least one succeeds, and at least one succeeding would mean we could rephrase that as 1 or 2, which we could then rephrase again, saying the event is not having 0 succeeding, not having both failing. And we have computed when there are 2 components, the probability of 2 failing. So let's see here, get this to type again. We would have 1 minus the 0.0081, which would be 0.0019. That is, let's see. Yeah, I was way off there. I believe that should be 0.9919. So let's bring up the calculator and double check that. Strange, I just brewed myself some coffee. I should not have made a mistake like that. 1 minus the previous answer of 0.0081. Yep, 0.9919. All right, so let's go to type that out. And although it's not asking, that wouldn't be unusual. That's well above 5%. Okay, how many components would be needed to in the structure so that the probability that the system will succeed is greater than 0.9999? I suspect that what they are looking for here is a short amount of trial and error. So we've got something pretty close to 0.9999 with this when there were 2 of them. Let's see what happens with 3 of them. That's getting closer to 0.9999. Let's go up to 4 components. Can't have a fraction of a component, by the way. So now we're getting 0.9999. That's 4 nines followed by 3439 approximately. And it would only get better from there with 5 or more. So we need at least 4 components. And that's it for now. See you in the next one. Take care, stay healthy.